We're back to longer videos because I got cut to 3-minute videos and I, for the life of me, couldn't figure out how to do that. So I gave up, I paid, I subscribed, and you know what? That's okay. It is worth it for you guys, and I really hope you enjoy this video. Okay, so 7.2 is about solving exponential equations. This is going to be like 6.4, but we're going to build on those concepts. So this warm-up is a review of many different things. Okay, so number 1 is a review of grade 9 stuff. I mean, you're taking these two terms and you're multiplying them together, but they have the same base. So all you're going to do is you're just going to add the exponents. And you know what? Since this is grade 9 stuff, I'm just going to give you all the answers. Okay, so keep the x as the base, and then your exponent should be 7. So same as this one, take the 2's, don't multiply them together, all right? The rule goes that you keep the same base, but you add the exponents together, so you get a 7. All right, so that was grade 9. Number 2a is grade 10, grade 11 kind of stuff where you're factoring. So the first thing you got to do is recognize that you have two different terms here and they're separated by a minus. Okay, so this is one gigantic term because of the multiplication. Now what do they have in common? Because I want to take that out as a common factor. It looks like this 2 to the power of x is common, so I'm going to take that out and I'm going to put all the leftovers in a bracket. So first of all, the leftovers are that minus sign. Now what's going to be left over from the first term if I take out the yellow? That's just going to be the 2 squared. And here's the difficult part. What's left from this guy if I divide out the common factor? So that's going to be just 1, and a lot of people put 0, which is incorrect. All right, I can go one step further where I actually figure out what's inside the brackets. So 2 squared is 4, minus 1 is going to be the 3. This is as far as we go. I know a lot of you guys will want to take the 2 and the 3 and multiply them together to get 6 to the power of x. That's not right because we gotta, think about bed mass here. So the 2 is going to interact with its exponent before it multiplies with the 3. Okay, so it's going to stay right as it is. 2b is a grade 12 type of question because I see the logs in there. So if we're going to factor, again, take a look at two terms, okay, separated by a minus, and what they have in common. So I'm seeing the x's. Now the logs look like they're common, but remember we always have to take into account the number behind it because the log is stuck to that number. So this is a log 4 versus a log 3. They're different. That means I'm just going to take out the x and I'm going to put the leftovers in a bracket. Okay, so the leftover here will be the log 4, you got your minus, and then the 2 log 3. If I didn't know anything about like any of the laws that we just learned about, I would just leave it like this. But since you know some of those logarithmic laws, let's start using them. I mean, we can put these guys together because they actually have the same base of invisible 10. Why don't we take the 2 and do a reverse power law and put it back as an exponent? Let's also combine these two logs because there's a minus in between by using a quotient law. Okay, so it might look something like this. So the 4 will be the numerator, and then since the 2 goes up on top as an exponent, we got 3 squared there. One last step would probably be just to square the 3. Okay, so this is the final answer and what a teacher would expect from you if you've already learned all the laws. Now let's continue on to today's lesson. All right, what I'm going to do is I'm going to show you questions just like in 6.4 where we're solving equations. We're going to do 4 of them. And you know what? I'm actually going to start with this one because, this one has unknowns on both sides that I have to figure out and solve for. This one actually only has 1 on one side. So, this one's probably the easier one to deal with. Okay, in 6.4, we solved these by changing it from exponential form, which is what it's in, to logarithmic form. So I'm going to show you two different methods, and they actually are both the same. You're going to log both sides. Okay, so we're just going to do the same thing, and then I'll show you each method separately. So when I log both sides, it looks something like this. The exponent is kind of like your variable is stuck as an exponent, so we kind of want to bring it down using the power law. Okay, so this is going to look like this. So bring the t minus 1 down, keep it in brackets, that's very important. The log 5 just goes beside it, and then you got equals log 3.92. Now the next step, I kind of did them both in one, is since I want the t, I'm just going to get rid of this log 5 on both sides by dividing the log 5 out. So I'm going to be left with the t minus 1 over here, and then the log 3.92 over log 5 over here. The last thing is to get rid of that negative 1. So you bring it over, it becomes a positive 1. So that's the final answer for method 1. Now method 2, you're going to do the same thing. You can take this guy, bring it down so you get the same thing as we did before. But instead of dividing the log 5 out, I kind of want to expand it and see if I get the same answer. So let's multiply it in and you get t log 5 minus 1 log 5. So that's right there. The t is multiplying this log 5, so let's just bring the other one over to the other side. It's going to become positive, so that's in green right there. All right, now remember this t is multiplying the log 5. Let's divide the log 5 out on both sides and you get a final answer that looks like this. Okay, you're going to be like, you did two different methods, shouldn't you get the same answer because they don't look the same? And I'm going to say, well, they actually are the same, because if I just worked on this side and I go, okay, let's write this as two separate fractions. So I'm going to take this guy, divide by log 5, and this guy, divide by log 5, and I get them like this. These guys end up canceling out to become a 1. So now you can see that this is actually the same as method number 1. It's really your choice what you want to do, but we'll probably be doing more of the second method in the following examples. Okay, so let's go backwards to A now. Now we have exponents with letters on both sides. So how are we going to do that? Okay, so start off the same way. I want you to log both sides. Now the problem was the exponents are your variables. I don't want them stuck up there. So bring them down using the power law. Don't forget your brackets if you have like a binomial or something like that. Just remember your brackets. Okay, now I'm going to use the method 2 from when I solved this question. I'm going to start to expand. All right, so this you're going to keep the same, and then it's going to be x log 3 minus 1 log 3. So I have that in green right here. Now, you have one term, you have another term, and this one's like a third term. Okay, I want the x terms to be together, so let's bring them over to the same side. This is going to become a negative now because it was a positive before and you brought it over. It's going to be a negative x log 3. Okay, now this is still a negative log 3 over here. So then how do I isolate x? Because I can't really put these guys together. I mean, you can use your calculator, but it actually says to leave answers in exact form. So they don't want you to calculate these decimals. What you do is kind of what we did in the warm-up. So you're going to start to factor. What do these terms, like this one and this one, have in common? They have the x's in common. Okay, let's take that out. All right, so I'm just going to leave this the same. I'm going to take the x's out, and here are your leftovers, log 2 minus log 3. Okay, now the x is by itself, and we can actually divide out that entire binomial and bring it to the other side. Okay, so your final answer looks just like this guy. All right, so I know it's a little bit tough, but I mean, let's do a couple more examples, and you'll kind of get the hang of it. They're basically the same. Okay, so question C. Again, you're just going to log both sides, bring the exponents down with brackets. All right, you're going to expand, so I did them in different colors. The green one is going to be x times log 8 plus 1 times log 8. The blue is going to be x times log 3 minus 1 times log 3. So far, so good? Okay, now bring all of your terms with x's to the left side, all the terms that have no x's to the right side. Okay, so I'm going to show you that I want this x on this side to be with this x. This guy doesn't have an x, so I'm going to bring it to this side to be with this guy that also has no x. Okay, so right here, this one becomes a negative because it was a positive before. This one's a positive, so it becomes a negative. All right. Remember, you can't put anything into your calculator because it says to leave answers in exact form. All right, now I have two x terms. Let's figure out how to separate that x by factoring. Okay, so they both have an x in common. Let's bring it to the front. And then all the leftovers will go into the bracket. So I'm keeping this guy nice and I guess the same as it was before. All right. Now to separate the x from that bracket, I'm just going to divide it out. So let's divide both sides by log 8 minus log 3. And then I get my final answer on the right-hand side, which is this complicated little guy. All right. So you know what? We've done a couple of these. Why don't you try the last one on your own? I will give you the final answer. So here you go. It's the exact same thing, same color coding if it helps you out. Okay, and if you guys have any questions, just send me a message down below.